Hello Year 8, this is lesson 13 in the Forces, Waves and Generating Electricity booklet. Yes, this investigation into the surface area of a solar cell and the current that it generates. What we're going to do is this piece of cardboard here, we are going to move this way and it's going to start to cover this solar cell. And the prediction that we've made is, as more of the solar cell is covered by the cardboard, less of the light energy from the lamp reaches the solar cell, this thing here, and so less electricity is generated, and so the current in milliamps will go down. Now, at the start, the solar cell was 9 centimeters by 6 centimeters. That gives us a surface area of 54 centimeters squared. We will be moving this piece of cardboard 1 centimeter along at a time, which means 1, 2, 3, 4, 5, 6 centimeters squared will be lost. So it's not 54 centimeters squared now. 6 centimeters squared has been covered by cardboard. So the remaining is 48 centimeters squared. Then we move the cardboard again further along, and another 1, 2, 3, 4, 5, 6 centimeters squared is lost. So now we go down to 42 centimeters squared. And so on and so on and so on until all of the solar cell is covered. And the surface area of the solar cell will be 0 centimeters squared. Let us briefly have a look at the video again. So we have here an experiment involving a lamp, a solar cell and a multimeter that is going to measure current. What we're going to do is this. The lamp is going to be 8 centimeters away from the solar cell. The solar cell is going to provide us with a current reading. The current reading is measured using our multimeter, and notice that the dial is at the 3 o'clock mark right there. It's giving us milliamps, and at the moment it's 4.17 milliamps, and 100% of the solar cell is exposed. Now I believe that to be 9 centimeters by 6 centimeters, so that is 54 centimeters squared is its surface area. What we're going to do now is we're going to take a piece of card and we are going to put that over sections of the solar cell. So if I put the card here like so, we have covered 6 centimeters squared because it's 1 centimeter wide by 6 centimeters long. So we now have 54 centimeters squared, take away 6, which is 48 centimeters squared, and now we're getting a new reading. And we keep on going. We move 1 centimeter along every time, but in essence that is 6 centimeters squared less every time we move the card along. And so as I move the card along, you should see that the current reading goes down. Once all of the solar cell is covered by the card, it will not surprise you to find out that the reading turns to 0. You will be collecting your results. So generating our results table, first off we want a heading, don't we? So surface area of of solar cell. Always put the units in the top heading, centimetres squared. That's our independent variable, and our dependent variable, what we're going to measure is the current. It's the flow of electricity, and that is in milliamps. Little m, big A. Now, the first surface area was 54 centimetres squared. 48, 42, 36, 30, 24, 18, 12, 6, 0. So now I've added in the current readings, and you can clearly see what's going on here at the moment. You should be able to spot that as we decrease the surface area of the solar cell in centimetres squared, then the current reading in milliamps also decreases. That's your big trend there, the big pattern. Don't forget to add in the result table itself. I put a box around it. I'll add in now, hopefully, some columns, and then finish off with the headings. And notice how the data itself has no units, because you've got the units at the top, and it's the same with the current. The current readings are here. They're to 2 decimal places, but you only put the units milliamps in once. Let's now complete the line graph, because it's a line graph because both of these variables are continuous. They are number values. Now, I'm going to label up the axes first. So, independent variable, horizontal, dependent variable, vertical. Surface area of solar cell. Don't forget the units, centimetres cubed. And then we've got current here in, don't forget the units, milliamps. Now, both start at 0, but the surface area, what's the biggest surface area? I've got to go up to 54. Now, be careful, careful, careful. We go up in 1s or 2s or 5s. We've got to get up to 54. Let's try this now. 1, 2, 3, 4, 5, 6. 1s are no good. Let's try 2s. 2, 4, 6, 8, 10, 12. No good. 5s. 5, 10, 15, 20, 25, 30. No good. We've done 1s, 2s, 5s. Now we go up to 10s. 10s, 20s, 30s, 40s, 50s, 60s. Yes, that works. 10s, 20s, 30 is right here. 40 is right here, 50 is right here, 60 is right here. Now the current, the biggest current is 4.17. I'm going to try 1s to start off with. 1, 2, 3, 4, 5. It works straight away. 1, 2. 1 is there. Not halfway down. That's wrong. 1, 2, 3, 4, 5. Okay. Now I'm going to plot the points. 54. 54 is right here. It's 54. And that was 4.17. There's 4.1, 4.2 is going to be right here. It's a cross, nothing else. That's the best we can do. 48. 48 is here. 3.32. Just about there. 42, 2.71, 2.5671 is about there. 36, 2. 30, 1.45 there. We're getting a curved line. I can see it straight away. 24 is 1.01. That's just about there. 18, there's 18. 18, 0.62, 0.5, 0.6, 0.62 is about there. 12, 0.29, about there. 6 is there, 0.08. And then at 0, it's 0. Now we put in a curved line of best fit. I shall do this in a different colour. It's a curved line. You can see that straight away. You can stop for a moment and then regather your thoughts. You can see it's a curved line of best fit. And there we have it. Excellent. Now, the final thing is a conclusion. Can we say that as we increase the surface area of the solar cell in centimetres squared, we also increase the current reading in milliamps? That's your conclusion. Why does that occur? Well, if you increase the surface area of the solar cell, more of the light energy from the lamp can strike the solar cell, and so more current in milliamps is generated. The bigger the solar cell, the more electricity, current, is going to be generated. Anyway, I do hope you've enjoyed this book. It's all about your key skills. Think about all the key skills that we've used today. You know, making a prediction, writing out a method, collecting some results, putting them into a results table, drawing a graph, taking or extracting information from your graph, generating a conclusion with some science in there as well, plus all the knowledge that we've looked at in this book. Brilliant. Well done. Thank you.